Okay, welcome to my channel, students, Academy Masters. And today in videos, this is lecture number 6. Okay, if you are new to the channel, don't forget to subscribe to channels. And now today we are going to start with the topic functional groups. So what is functional group? An atom or group of atoms. Functional group is what? It can be an atom or a group of atoms, which gives that determines the characteristic chemical properties of an organic compound. So by the presence of that particular atom or group of atom, the characteristic properties or the chemical properties or the physical properties of that particular compound is determined. Okay, so that is called as what? Functional group. For example, you can see here CH3OH. So if this CHOH was not there, this is normal hydrocarbon, but due to the presence of OH, what it has become? It has become a alcohol, right? So this is nothing but OH here, it is nothing but it is called as what? Functional group. Due to the presence of OH, the chemical properties of these hydrocarbons will change. Now another example, let us see CH3, CH2, CHO. So earlier, if CHO is not there, then CH3 it will be there. They will have different chemical properties, okay or not? But due to the presence of CHO, now this CHO will determines the characteristic or chemical properties of these compounds. So this group is called as what? Functional group. Because of the presence of this functional group, the characteristic chemical properties of these compounds, hydrocarbon, has changed. So this is called as what? Functional group. Functional group is something that because of which the functional group is something that because of which the characteristic chemical properties of the compounds will change. Okay, fine, hope you have understood. Now let's move on to the homologous series. So what is homologous series? A series of similarly constituted compound. A series of similarly constituted compound means a series of those compounds which are made up of similar types of atoms or the elements. Okay, a series of similarly constituted compounds in which the member possesses the same functional group, in which each member will be possessing the same functional group and have similar chemical characteristics. So homologous series is nothing but a similarly constituted compounds in which each member they will have the same functional group and same characteristic properties. So example, we will take it and then we'll try to understand examples of. Now you can see that the functional groups are divided into different types, okay or not? On the basis of their functional groups, they are divided into different types, and they are nothing but we call it as families. Okay, so homologous, they are of different families are there. So examples of alcohol family. Alcohol family, here you see CH3OH, 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 everywhere OH is there. So this is nothing but homologous series of alcohol family, okay or not? So here we have written CH3OH. So always remember, in homologous series you will see that each you can say that each next consecutive compounds will be varying with each other with a difference of CH2. So see here CH3OH, here CH3 CH2OH, here CH3 CH2 CH2OH. So you just see every constituted compounds, they are differing by how much? They are differing by CH2, CH2 and CH2. Got it or not? Each constituted compounds will be differing by the difference of CH2. Okay, so this is a homologous series. Now let us go to the characteristic of this homologous series. Okay, now the characteristic of homologous series. So the characteristic of homologous series is what? What are the characteristics? This characteristic is very important, dear students. It comes in your exam for 2 marks, so definitely you should study properly. Okay, so characteristic of homologous series. So all the members of the series are separated by a general can be represented by a general formula. What is the general formula? CnH2n plus 1. Means all the members we can represent it by using this formula. Okay, two successive members differ in their formula by CH2. Okay, That means what? See here, two members of the family, there are different members, as I told you, like alcohol, aldehyde, ketones, all these are families, different families. So two successive members, suppose here we are considering alcohol family, then CH3OH, and another one is CH3CH2 and OH. So this is two successive members, okay, of which family? Of alcohol family. So these two successive member of the alcohol family, they differ in what? Here you see CH3, here is CH3OH, OH. They only differ in the present, their molecular formula only differ by what? CH2. That is the meaning of this. Two successive member differ in their formula by CH2. So this is one family, alcohol family. Here you see CH3OH, and here molecular formula is CH3CH2OH. That means these two successive member of alcohol family, they differ by a molecular formula. By these two alcohol family, they differ in what? They differ in formula only by CH2. That is the meaning of it. Okay, got it? So now we will be going for third. The different member in the family have common functional group. So different member in the family has a common functional group. Means what? See here, CH3OH and CH3CH2OH. So this is the different member of the family. Okay, this is the first and this is the second member of the family, but their functional group is what? Same or not? So that is what it is written. Different member in the family have common functional group. Okay, understood? Now the member in any particular family have almost identical chemical properties. Means what? You can say CH3OH and CH3CH2OH. These are the members in the family. So these two members, they will definitely have identical chemical properties. That is what the characteristic number 4 says. Okay, understood, dear students? Okay, now coming to the next topic, that is isomerism. This is very important topic and you have learned in class 10 as well, but once again we will be learning it. Isomerism, what is that? Two or more compounds having same molecular formula but different physical and chemical properties are called as what? Isomers. And the phenomena of existence of such two isomers are known as what? Isomerism. Okay, so I have written here two or more compounds having same molecular formula but different physical and chemical properties are called as isomers, and the phenomena of their existence is called as isomerism. So for example, one example, let us understand what is isomers. So butane, so formula is C4H10. Okay, just imagine formula is C4H10. So this C4H10, CH3, CH2, CH2, CH3, this way also it is coming butane. Another way, CH3, CH, CH3, CH, here one bond is coming, right? So here also you see the number of carbon is how much? 4. So 4, and hydrogens will be 10. So that means this compound's molecular formula is what? C4H10, and this compound's also molecular formula is what? C4H10. Okay, so their molecular formula is same, but if you see their structures, it is different. So this kind of these two will be called as what? Isomers, and the phenomena will be called as isomerisms. These two will be isomers. Which type of isomers we will be studying in the later part. Okay, but these two will be called as isomers. Why they are isomer? Because their chemical property is same, but their because their molecular formula is same, but their physical and chemical properties will be definitely different. Okay, so they are called as isomers, and the phenomena is called as isomerism. So you can take it down, students. Now we will move on to types of isomerism. Okay. Okay, so now we are going to discuss about types of isomerisms. So isomerisms are mainly divided into two types. The first type is structural isomerism, and the second type is stereoisomerism. So what is the structural isomerism? So structural isomerisms are those compounds which have the same molecular formula but different structure. For example, you can say already I have shown you one example like CH3, CH2, CH2, and here it is CH3. So this is one compound. Okay, the name of the compound is what? Butane. So this compound name is butane. Now same compound, if I arrange it in this way, CH3, CH, CH3, and here it is CH3. So you see, count the number of carbon here, 1 2 3 4, 4 carbons, so it will be C4. H is how much? 10, so H10. So molecular formula is C4H10. This compound 1 2 3 4, 4 carbon, and molecular formula is here also 10. Okay, so these two compounds, the name of this compound will be what? Propan. The name of the compound will be 2-methyl propan, right? Propane. The name of this compound is 2-methyl propane, and this one is butane. So this butane and 2-methyl propane, you see their molecular formula is same, but they differ in the structures. Here it has a branch and here it has what? Straight chain structure. So these two, it will be called as what? Structural isomers. Okay, and the phenomena is called as what? Isomerism. Hope you have understood, dear students, what is structural isomerism. Okay, now next one is what? The next type is what? Geometrical stereoisomerism. So stereoisomerisms are those compounds which have same structural formula. They will have same structural formula, but only they will differ in the three-dimensional arrangement of the atoms in a molecules. That means what? The arrangement of the atoms in a molecules in a three-dimensional space, that is in open space, it will be different. Their structural formula will be same, but the arrangement of the molecules will be different. Okay, so this kind of isomerism, we call it as what? Stereoisomerisms. Now we are going to discuss one by one the structural isomerisms, and then we will come to the stereoisomerism. Now the first one is what? Chain isomerism. Okay, so what is chain isomerism? The same example which I gave you now, they will have the same molecular formula, but they will differ in the structure. So that one we call it as a what? Chain isomerism. One will have branch chain, another one will have straight chain, so they will be considered as chain isomers, and the phenomena will be called as isomerism. Position isomers. So position isomers, here also, here they will differ only in the positions of the you can say they will differ in the position of the functional group. For example, you can see here, this one example is CH3 CH2 OH. So this is one compound, so it is called as ethanol. Another compound is CH3 CH3OH, right? So this is what? Propanol. Okay, another one we will take CH3 CH3. Okay, got it? So it will be equals to OH here. So here you see here, what is the number of carbon? 1 2 3 carbons, and what is the number of hydrogen? 4 7. Here you see 6 7 8. Oh, so here it will be, wait. So you can take another example like CH3 CH2 CH2 CH2, and or CHOH, you write it here, OH. Another examples, you take it CH3 CH3, and here it will be OH. Got it? So here you will see that 2 4 6, here it is 7 1 8. So here you write it like this. So it will be how much? See, carbon is how much? 1 2 3 carbons, and how many hydrogen? 5 2 7 and 1 8. So H 8 and O. So here you see 1 2 3 carbons, and hydrogen 3 6 and 2 8. So H 8 and 1 oxygen. So see, their molecular formula is same, but they differ only in the placement of the functional group. The position of the functional group is different, so they are called as what? Positional isomerism. Don't worry, right now I'm just introducing it. After this we will be explaining it point by point. Okay, next is functional isomerism. So functional isomerisms are those isomers in which you will see that their molecular formula will be same, but the functional group which is present in both the isomers, it will be different. So they are called as what? Functional isomerism. Metamerism is what? The functional group also will be same, but the number of carbon atom present on the left and the right hand side of the functional group will be different. So they are called as what? Metamerism. And next is fifth one is tautomerism. Tautomerism is nothing but it is a special type of functional isomerism only, in which each group is in each functional groups it will be in equilibrium constant with each other. So all these five I'll be explaining to you after I finish up this. Then I will, in the next lectures, I will be explaining each and every point along with the definitions. Okay. Now coming to this side, stereoisomerism. Here we have geometrical isomerism. Geometrical isomerism, basically it is not in your syllabus. You will be studying in class 12. Then optical isomerism also, it is a part of the class 12 syllabus. And then conformational isomerism, the types of isomerism. So the first type under structural isomerism is what? Chain isomerism. Okay, so what is chain isomerism? Same thing again, the compound having the same molecular formula. Okay, up to here they everywhere same. The compound having the same molecular formula but different arrangement of carbon chain in a molecules. Okay, the molecular formula will be same, but the arrangement of the carbon chain here it will be different. Okay, that means one may be straight chain, another may be a branch, all those things may be there. Okay, so it is called as chain isomerism. Example, you take a butane. So molecular formula is C4H10, right? So what we have done, in one way there is in one isomers, this isomer it will be written as CH3, CH2, CH2, CH3. So this is one isomer in which all the carbon atoms are arranged in a straight chain. Okay, and its name is butane. Now another one, CH3, CH, CH3, CH. So here we have arranged it in a branch. So what will be the name of it? 3-methyl propane, and this one name is butane. And if you check their molecular formula, 1, 2, 3, 4, and remaining hydrogen 10. Here also 1, 2, 3, 4, hydrogen 10. So molecular formula is same, but what they are differing? They are differing in the arrangement of carbon. Okay, they are different in the arrangement of carbon chain. So here you see carbon chain is straight, here carbon chain is branch. So these two isomers, it will be called as what? Chain isomerism. They are under, these two will be under which isomerism? They will be under chain isomerism. Okay. Now coming to the second one, position isomerism. So in position isomerism, what happens? The molecular formula will be same, but they will differ in the position of functional group. The position of functional group will be different. Their functional group will be same, but the position of the functional group will be different. For example, you see molecular formula here C3H7OH. This is the molecular formula. So this molecular formula we can write it in this way: CH3, CH2, CH2OH. So this is what? Propane. So propanes, you will see the functional group is this one. This OH is a functional group. We have arranged the OH in the last. Okay. In which positions? 1, 2, 3. Position number 1. Okay. Now another example, you take 1, 2, 3. Here you have arranged the OH in position number 2. And what is the name here? Propan-2-ol. So here it is propanol and this is propan-2-ol. So in these two compounds, if you see their molecular formula is C3H7OH, but their position of the functional group here it is 1 and here the position of functional group is 2. So they have different functional group position, but their molecular formula is same. Such kind of isomers we call it as what? Are called as positional isomers. Okay, got it? So you can take it down. Then we'll move to the remaining 3. We will do it now. So the third type of isomerism is what? Functional isomerism. Okay. So what is functional isomerism? It is very simple. The compounds having the same molecular formula, but they differ in the functional group, but different functional group. The compound have the same molecular formula, but different functional groups are called as functional isomer, and the phenomena we will be calling it as functional isomerism. Okay, so that is what I have written here. So let's take an example, C2H6O. So this is the function, this is the molecular formula, and if you write it this one, then it will be written as CH3 CH2OH. So this one is what? This is what? Ethanol. And what is the molecular formula here? How many carbon? 2. How many hydrogen? 6. 5, 1, 6 and 1 O. So the molecular formula is this one. So this is ethanol. Another example is methoxymethane. So CH3O CH3. So here also you see hydrogen is 6, carbon 2, oxygen 1. So molecular formula is same, but here the functional group is this one, OH. OH is called as functional group, and what is it? Alcohol. Okay, and here the functional group is this one, ether. Okay, got it or not? So this is the functional group here, and the functional group here it is OH, and here the functional group is O. So they are having same molecular formula, but their functional group is what? Different. So they are called as functional isomerism or functional isomer. Okay, now coming to the fourth one, metamerism. This is very important. Try to understand. Sometimes short questions comes for 1 mark. What is metamerism? So you have to listen it very carefully and try to understand. So the compound having same molecular formula, that is everywhere there, but different number of carbon atom on either side of the functional groups. Those compounds which has same molecular formula, okay, but the number of carbon atom on the either side of the functional group will be different. They are called as what? Metamers, and the phenomena we call it as metamerism. For example, you see this compound pentan 3,1. So here the functional group is CO. This is functional group, okay, the carbonyl group. This is the functional group, carbonyl group. Okay, so it is nothing but we call it as a ketone. This is a ketone group. Okay, so on CO is the functional group. So functional group ka right hand side, left hand side you see 2 carbons, and left hand side you see 2 carbons. Here both left and right you can see equal number of carbons is there. Okay, but here in this compound you see the left side it is only 1 carbon, and the right side there are 3 carbons. So these 2 compounds, if you check their molecular formula, C1 2 3 4 5 5 H10O, C1 2 3 4 5 H10 and O. So the molecular formula of these 2 compounds are same, but the number of carbon on the left and the right side of the functional group is different. Here it is equal and here it is different. So these 2 are called as what? Metamers, and the phenomena we call it as metamerism. Hope dear students you have understood, got a clear idea on metamerism. Okay, so you can take it down. Okay, the last one is tautomerism. So this is special type of functional isomerism in which the isomer differ in arrangement of atoms. So in this tautomerism you will see that the isomers, they will be differing in the arrangement of the atoms, but they exist in dynamic equilibrium with each other, and this phenomena is termed as tautomerism. So you see here CH3C, CH3O. So here the double bond position is what? 1, 2. Second position you can see the double bond is there. Okay, so it is propan 1. Okay, so here the group which is present due to the arrangement of the atoms, this is called as keto groups. Here ketone groups is present, but it is the same. And how many carbons are there? 1 2 3, and hydrogen is 6 and oxygen 1. Now this indicates equilibrium, or okay, this is equilibrium in dynamic equilibrium. So representation is this one, CH2 double bond C, CH3OH. So here you see the double bond compositions is 1, and here the double bond composition is 2, and here the functional group was what? Here functional group was ketone, and here the functional group is OH. So this is nothing but it is a type of functional isomerism, only a special type of functional isomerism. Okay, got it? In which they both the isomers, they are in dynamic equilibrium with each others. So one is called as propan 1 and another one is called as propan 2 1 all. So this is a tautomerisms. Okay dear students, so in today's lectures we have covered up the isomerism and its types. Okay, so in the next lectures we will be covering some new topics. Okay, so for today if I prolong, then the videos will become too long, okay, which you will not be liking it. So I will conclude today's lecture here, And dear students, if you are new to the channel, please don't forget to like and subscribe your channel Academy Master, so that you can get new notifications whenever I be uploading the videos. And remember, this is the first YouTube channel which is providing you on the spot notes along with the explanations. So don't hesitate to share the videos with your friends, and don't forget to subscribe my channel. Okay, so thank you so much.